Good morning, everyone. Welcome, and we are very excited to be here today with you all at this year's Enterprise Data World Conference. How many of you all are experiencing data quality challenges? Let me ask a question. I guess that's why you're all here today. And we hope to, the good news is, we hope to give you all some insights about the data quality management, how we have done at our organization, and how we have overcome that, so that all led to the operational excellence effort at our organization. I'm Sumalata Bachu, Senior Director at FINRA, leading big data operations. I'm here today with two of my colleagues, Troy Eads, who is Senior Director in Market Regulation Technology, and Abhishek Singh, who is Lead Data Operations Engineer in the technology at FINRA. In today's presentation, we're going to talk about what is our organization, what do we do, and what are some of the challenges that we have related to the data quality, and how we have overcome that, and then how all that led to the operational excellence effort. I know you all cannot wait, so let's get started. So before we start, our organization is called FINRA, FINRA, Financial Industry and Regulatory Authority. Our mission is to protect investors by making sure markets operate fairly and honestly and no market manipulation occurring. We regulate and monitor the brokerage industry and the stock markets in the US. I'm sure some of you are all investors and you want the markets to be safe. And we collect massive amounts of data. And I'll go some of the statistics in the next slides. And when we collect these massive amounts of data from various exchanges and firms who do security trading on a day-to-day basis, we use this on top of that to surveil the market events to detect fraud, abuse, insider trading, and market manipulation. All sounds scary, but we do it for a good reason. We discipline those who break the rules, and we deter any misconduct by enforcing the rules. For the next two slides, I'm just going to go over some of the statistics, what we have at our organization, just to explain the scale about the data. At FINRA, we oversee about 620,000 broker-dealers' data, looking for compliance rules and security laws. We regulate 3,300 security firms. And I'm not bragging, but our organization, FINRA, has been named as the first place to work in the IT in the mid-sized companies. Another slide about the statistics. As I mentioned, we collect really massive amounts of data, and we process 600 billion transactions per day. And we work with 24 different exchanges on any given day in order to perform the surveillance and then perform the regulatory functions at FINRA in the cloud. We spin up about 300,000 compute edges and nodes, meaning those are all the servers we spin up and we spin down to do the market processing. At FINRA, we process 500 petabyte scale of data. It is really, really huge. And just a small analogy, we are also going to go very soon to exabyte. FINRA is going towards like a data-driven organization. And just for those who do not know, exabyte is extreme big data processing. And 1 petabyte is equal, if you can imagine, it's the size of Earth, whereas 1 gigabyte is the size of the sun, and the sun is 108 times or 109 times bigger than the Earth. So you can imagine that's the volume of the data we process. Now, enough about statistics. I'm just going to go over our ecosystem as what we have at FINRA. This data lake architecture supports entire FINRA big data processing. We have divided into 5 sections: data ingestion, data processing, search and discovery, analytics, and then cataloging and storage. Data ingestion is really the first step where we collect the data. We collect the data from web application and also through secure file transfer method, machine to machine. We collect approximately from 200 external data sources. The data comes structured, unstructured, semi-structured, And the data, what we collect is not only just market data of transactions for equities and options, but we also collect exam data, registration data, criminal history data, and so forth. The data comes in at different intervals, different data types, and that is the main challenge. We have to design the workloads in order to process all that data. The next section is processing. Once we collect the data, we do want to process the data. But before we process, we have many validations that we perform on the source data. And then we transform the data by running big Spark workloads. And then we enrich the data again by running the Spark workloads. Now that we have ingested the data, we process the data, users wanted to discover the data. So at FINRA, we have built a self-service, secure, comprehensive portal called UDC, Universal Data Catalog, where users, based on their privilege, can come in and self-discover the data, understand the data, what that means. Now that they know what the data looks like, they wanted to perform analytics on it. And we have a very huge footprint at FINRA where we use different data science tools like Dataiku and Domino to perform the machine learning model analytics. We use Spark workloads to process and understand and analyze big data processing. And then for ad hoc query tools, we use Presto. And all this processing runs in a batch surveillance form for efficiencies. We have a biggest data lake called data management, where we register the data and catalog that data. Source data comes in and gets registered. Process data comes in, and we register that after post-ETL. And then, as I mentioned, the storage, which I already went over the numbers, it's really huge. Now, let's talk about some of the big data challenges that we have at FINRA. I'm going to start from right to left. How many of you all know 4 Vs, heard about 4 Vs in big data processing? I'm sure a lot of you all, I see nods. And it all means lots of data. Volume, the first V is volume, second V is variety, third V is velocity, and fourth V is veracity. With volume comes more challenges, we all know that. And I'm sure how many of you all heard Robinhood event, GameStop event. So that was the event when we actually had highest peak volume that we hit. More volume means more source data issues, more processing issues, more infrastructure issues. Variety, as I mentioned, we get different type of data formats. We get in Parquet format, we get in ORC format, different variety of data types as well. So we have to design the workloads in order to meet these different types of data types. And velocity. We all know we only have 24 hours in a day. I wish we had more. But if everybody submits the data at the nth hour of the processing trade day time, we do not have enough time to process the data. And that's the biggest challenge we have. And if external data sources send the data in the last minute, that just trips off us and complete pipeline breaks, downstreams cannot process, and all the sorts of issues arise. Veracity. Veracity is nothing but data availability and data quality. Data availability is having the data available at the right time, as the name says. Data quality is making sure data is complete, accurate, not corrupted, and so forth. At FINRA, we take data quality very seriously because that really hinders our mission to accomplish for regulatory purposes. With that, I'm going to pass on to Troy, who's going to talk further about next slides.
I'll take that. Thank you very much. If I move over there, is it going to cause you problems? Or great. I'm a lefty, so I like to look that direction. Well, since we're here at a place called Enterprise Data World, obviously we're concerned with data. So if you're concerned with data, ultimately data quality needs to be at the forefront of our minds as well. And here's just a simple definition of data quality. I'm sure there's a ton of them out there that you could utilize. It's just the accuracy, the completeness, the consistency, and the reliability of the data, ensuring it's fit for whatever intended purpose you happen to be using it for in your organization. Now, it's crucial, obviously, for a variety of things. We'll talk about some of these in detail, but obviously decision-making, compliance, customer trust, operational efficiency, and the like. But when we kind of look at a data quality, we look at a life cycle across the board here, and just these 4 stages kind of help us to kind of determine exactly how we want to set that up. So if you're going to set up a data quality program, right, the very first thing you have to understand is the data itself, right? It's very difficult to understand. If you don't know what's coming in through your data, it's hard to set up that quality. So your first step, you got to analyze the data, understand the data. Once you understand the data, you can begin to go ahead and set up some of your data quality standards, data quality checks and the like. And of course, once you have those checks, you can implement them. And once you have them implemented, you can go ahead and begin reporting on them, not only to your tech teams, but also to your business users as well. So let's dig into a little bit more detail. Now, I'm going to approach this from obviously what we do at FINRA, right? I hope you can draw some correlations about some of the things that you do at your company. Obviously, it's difficult to address every company in the room and how you operate and how you function, what your size of data is, et cetera. And we're just going to touch on these couple things right here. Basically, what we talked about is decision making, right? You have to be able to trust the data if you're going to draw accurate insights, if you're going to make proper decisions, if you're going to trust the analytics that come out of it. You have to be able to ultimately trust your data. If you don't, very possibly you lead to making faulty decisions. You lead to making decisions that may cost your company money, or even worse at times, it might harm the reputational integrity of your company or lower the value of your company in the eyes of your consumers. So data quality is of the utmost importance. Now, at FINRA, we're obviously, as Sumalatha had mentioned, we're obviously focused on market events and those kinds of things. We do perform market surveillances on fixed income, equity, and options markets. And so that's the bulk of a lot of what we do. And then we also have some enhanced risk assessment. So, if we don't have proper data quality, it's very possible that we might miss things like manipulation going on in the marketplace. Or even if we're able to identify manipulation going on in the marketplace, we may not be able to get to the bottom of who actually caused it, and that's not a good thing. The SEC doesn't care for that either, right? So, and then we might also, because we have a variety, we have a few hundred surveillances that are running across all of these kinds of things, and the last thing we want to do is waste our analysts and investigators' time with regards to spurious alerts that come up and have to waste their, they're just going off and chasing down rabbit holes for things that have no value whatsoever. And then also on that side of things, as I said, we have risk assessment of firms. So we want to make sure that firms have appropriate capital to begin trading, to handle their trading. We want to make sure that their trading that they're going out and doing isn't of risky strategies. Because you'd be very surprised if you kind of remember back to some of the kind of events that have occurred in the past in the marketplace, like a flash crash that occurred more than a decade ago now. Those kinds of things can happen very quickly in the marketplace. A single trade can trigger some very serious events. So we want to make sure that our firms aren't engaging in risky strategies, which might also cause damage to the marketplace. So in order to do that, we have to have accurate data and quality data. And then, of course, efficient investigations and audits. I don't know about you, not a fan of internal audits, but they are a necessary thing in the company. I get it, but the last thing that I want to do is extend an internal audit because of bad data and problems. Don't want to waste resources and time doing those kinds of things. And of course, data governance and stewardship. It's ultimately all about the quality of the data. Policies are built from a data governance perspective. And if you have incorrect data, you might also lead to incorrect policies. I want to focus a little bit on what we do at FINRA, just how we go through this process. Now, Sumalatha has mentioned the overwhelming majority of our data comes from external sources, right? We are not the market, right? We surveil the market. So we have a variety of incoming data sources to the tune of, obviously, billions of records a day. And so we have to have checks on our external data sources. As an example, and I'm going to use a kind of a consistent example throughout this, and this is our main surveillance data for, say, our options and our equities data. Just to give you a sense, that one data set that we run, and so we take in this external data, we process it internally and do many other things to it before we pass it on to our surveillances. That data set runs between 50, depending on market volatility, between 50 and 100 billion records a day. So the last thing we want to do is reprocess, right? So what we do is we run checks on our external data sources before we ever get to the point of processing. It's the very first thing that we go out and do to see if there are duplicates in the data, are there values that we're not expecting that's going to cause job failures, those kinds of things along the way, so that we can become aware of that type of stuff. And it also requires us to kind of stay in contact with our external data provider, right? As Sumalatha mentioned, there are 33 exchanges that report to this external provider. There are thousands of firms, right? There are constant data issues. They don't go away. There's never such a thing as not having a data issue in this data set. They exist every day. The question is, how severe are they, right? So we have notifications, we stay on top of that, we meet with our technology users, we make them aware of the significant data issues that are in the data every week, and they take those back to their business users if there's any particular impact, and so that's just constant checks. And then of course, after we do this, right, we've got to process our internal data set. And we run quality checks on that once it's done processing, right? Let's make sure that we have a quality product that comes out of that. We haven't screwed something up in the process of running that process itself. And between the checks that we do here and the checks that we do here, about 2,500 different data checks for this one data set. Now it's a wide data set, it's like 360 columns. But we run a number of checks on it, and they run the gamut from fatal checks that'll cause our jobs to fail to ultimately just informational checks saying, hey, you might want to take a look at this. Oftentimes we have a tendency to think about data quality as finding the problems, right? We want to also prevent the problems if we can, where they exist. And so we stay in contact with our users, our external data source to see if there are things coming down the pike. We have biweekly meetings with them to understand what's happening. If, say, an exchange introduces a new order type, we got to make changes. We have to account for that. Otherwise, we might have a job that fails, or we may display data incorrectly, which then impacts our surveillances. And one of the things we've tried to do is to get our developers even to think about problems as they see it. As they go through unit tests, look, if you see something, say something. Like you'll see at the airport when you fly back home, right? If you see something, say something. Don't just blow it off. And what we find is the more they understand the business, the more they're able to pick up on potential data issues in the data. And then we've really focused on trying to get our business users as well to pick out data issues and data problems. We do that specifically. We actually have a wiki where we allow them to come and post questions about the data, and we provide the answers on there so that all can see, I guess, kind of a quasi Stack Overflow type of process. And we have a bi-weekly meeting with our business users as well to go ahead and state and say, hey, here's what we've got coming with releases. This is some of the potential data problems that we see in the data. We want you to be aware of them. We get priorities from them as well. When we think about data quality dimensions, these 7 things, look, is your data accurate? Is it complete? Is it consistent? Did you get all the records? And here's not just did you get all the records, because we're skeptics at heart, right? How do you know that your external data provider provided you all the records? So beyond just a simple row count, you need to do things where, if there's distinct values that you expect to see in the data, if there's standard deviation checks that you need to do for, or percentage checks to say, hey, something's out of line here. We got to make sure that this is covered and okay. Is it consistent for values that you expect to be not null? Are they not null? Are they filled in with something? If you expect specific values in a field, what happens if you get a value that you never expect? Would you even know that you got a value that you didn't expect, right? You got to have checks for those kinds of things. And are you getting that data out to your business users in a timely fashion, meeting the SLA so they can do their work? And we think if you can complete those 4, if it's accurate, complete, consistent, and timely, it's ultimately going to be reliable, it's going to be valuable, and they're going to be able to interpret it. And I'm running out of time, obviously, and so I won't go through this. One thing I want to touch on, we do table level and column level checks, but one of the things we found invaluable is a comparison check. And our team has developed a comparison tool. And in doing so, what happens is every time we run a new release, we get ready to go out and do that. We scan the whole table for every column to see, are we expecting for a date that we ran previously in production, we ran the new code against that. And do we see changes that occur in columns that we don't expect to have changes? And we have actually been saved a number of times by these kinds of things. So I'm going to turn it over to Sumalatha. She's going to talk more about the operations side of things.
Thank you, Troy. I'm back again. So Troy spoke about from the applications perspective. I'm going to talk from the operations perspective. Then these 6 key areas are where we actually made a lot of improvements, which really helped us to overcome these problems. So the first one is the data volume. And as we have been alluding to, that's the biggest problem where we cannot predict as the market volumes are really unpredictable. So we have done 3 things to overcome that to a great extent. The first one is tech enhancements and tech upgrades. We constantly try not to maintain tech debt and move along. And we scale the infrastructure. We have written in algorithms where the infrastructure scales to meet the volume as they grow. And the beauty of that is we are in cloud, so it really helps us to move that. And the other thing is we have the infrastructure in multi-AZ, disaster recovery posture. So if there's a failure, we have like that kind of resiliency. We also have built a lot of enhanced automation, which is self-healing. When a process fails, it starts where it failed instead of starting from the beginning. The next one is data quality checks. I'm going to quickly share a small story. 2016, we had really a major issue where one of the exchange sent us the data. We processed it, the workload ran, and downstreams consumed the data. Time went by, and then a few days later, one of the customer called us saying, hey, I'm not seeing the data that I'm supposed to be in the query tools. And then we, all hands on deck, we tried to troubleshoot, and then we found that it was a Spark bug in the application code, which really registered the data as a 0-byte file. The check simply sounds very simple, but we didn't have that at that time. That really caused a lot of issues. And then as Troy was saying, we don't want to report to SEC, but we had to report that event. So it really caused a really big issue. So since then, we have evolved with our framework to really expand all the data quality checks, and we're still continuing to grow there. And Troy already mentioned with a lot of this, we don't want to rerun or reprocess or historical data loads when we see these issues. So what we did is a lot of, again, automation and enhanced monitoring to know exactly when these issues arise. Because when the issues arise, it's not only human hours of work to do reprocessing, but infrastructure cost in the cloud. If it's on-premise, it's a different story. Continuous improvements, right? So for anything, we want to have continuous improvements. So we have done 3 things at FINRA. First one is process change. We really implemented a process where when we have the issue, we do root cause analysis. We do remediation steps when we understand so we can prevent it from happening. And then culture change. Troy already mentioned a little bit about it, where data quality is not only finding out problems in production, but finding out from the development and from assurance, from UAT, and so forth. Recently, FINRA launched Data Management Governance Office, whose mission is to really expand these data quality checks further and to enhance the governance model. SLA tracking, service level agreements, I'm sure you guys are familiar with it, and we don't want to miss them and then make our customer unhappy. So we have implemented a lot of checks and balances to measure these SLAs, and then it helps really to improve further. And finally, executive level reporting and tracking. And we all know we want to keep our senior leadership informed, but not just sending them email or something, but we built a lot of enhanced consolidated dashboards where they can come in at a portfolio level and look at their data, look at their portfolio issues. So it's like a one-stop view where they can make data-driven decisions. So all this really helped us one step ahead into the operational excellence effort. And again, Troy mentioned this. In the interest of time, I'm going to skim through. So we have three types of different checks: fatal, non-fatal, informational. When the fatal checks happen, it's like, oh my God, sky is falling. We stop the processing, we halt the processing, and then all hands on deck. We try to troubleshoot, remediate, and then proceed. It can be source data issue, it can be infrastructure issue, or it can be human error as well. Non-fatal or mostly has to do with, it's good to know there's a problem, but we don't stop the processing. We go back, data fix it, or rerun, or the necessary steps we take. Informational, totally informational. We wanted to know the trend. We want if a new firm sent a new exchange sent a new symbol or new data type, the percentage of the volume spiked. We want to know so we can predict and then take actions appropriately. In all these, we have alerts and we get the emails, we have dashboards and all sorts of good things. This is a honeycomb diagram that we have for operational data quality checks. It's a heat map, and I'm not going to go each section, but we have primarily three sections: source data quality checks, reconciliation checks, and machine learning checks. The source data quality checks primarily focuses on the source data. Did I get my data completely? Did I get the data format that I'm expecting correctly? Did we get any zero records, zero files? So it's like really validating at the source level. We have hundreds and hundreds of checks for all the external data sources data that we get. Reconciliation checks are basically making sure at every step of the pipeline, we are doing this comparison and making sure, did we get X amount of data? Did we process the same amount, or did we drop anything on the floor? We all know how hard it is to clean once it's on the floor. And then, as Troy alluded to, not only doing the checks, but we also want to predict that the issue is going to happen. So we have implemented many machine learning checks to detect data anomalies based on the historical data using time series algorithms. With that, nice segue into operational excellence effort, and I'm going to pass on to Abhishek, who is going to go through the next slides.
Thank you, Samrita. Hello, everyone. My name is Abhishek Singh. I'm a lead at FINRA for Big Data Operations. Glad to be here. So what we heard till now is data quality is a major challenge. And poor data quality leads to revenue issues, leads to compliance issues. One of the most less talked about is wasted engineering effort. How many times have you been in a scenario where the dashboard is broken and people are hunting for the right data and it takes days sometimes to fix it? It's all around the data, people wasting their time around it. So with operational excellence, we at FINRA try to deliver reliable and trustworthy data to our stakeholders and to our executives. Machine learning checks. Before even we go there, we need to talk about why we need machine learning in data quality. So data engineering and overall data landscape has been evolving just like how software evolved. However, with a delay. What do I mean? With the emergence of cloud, making softwares and getting infrastructure became very easy. We could have our CI/CD pipelines, put our softwares very quickly into production. But that led to more incoming data into our systems. When more data comes in, then data reliability becomes an issue. And with machine learning at FINRA, that's what we are trying to solve. Now, why machine learning checks? One other thing I would quickly touch upon is, historically, all our data quality checks had been through rule-based checks. Subject matter experts understand the data, they write the rules. But with the 4 V's Sumatha touched upon, sometimes the data changes, the volume increases, and it's not scalable. And a lot of things get dropped on the floor. So with machine learning, we at FINRA are trying to get some additional, well, don't get me wrong, those rule-based checks are needed and are good, but we need something more. And with machine learning, we can do these additional checks, and we can do much more and much faster in a scalable way. Sometimes with the variety of data, finding irregularities in data through rules is almost impossible. But with machine, it is possible. And last thing I'll touch upon why machine learning checks are needed is with the volume of data, actually machine learning is are happier models. More data you feed to a machine, more it learns about it. So that way it also helps us. Well, I think we all can agree to this, that there are many types of data quality issues in a data, but some of them we have listed here. It can check on your metadata. It can check on any structured or unstructured data. It can also alert you if there's a data missing in it, or sometimes there's a distribution of data, especially how we get it in a time series manner. It can tell you that there's some chunk of data missing in your data set. I'll also touch upon one quick thing. It's a very good practice to do because most of the enterprises here will have data lineage. Nobody is in a silo anymore. Everybody is a producer and consumer. So earlier you implement in your whole pipeline those data quality checks, the less costly it would be to fix it later. All right. I'm not sure how many of you actually have implemented models. If you a raise of hand, please. Okay, so I'll quickly touch upon these slides too. So how we do machine learning checks. So once we have done the data collection, one of the key things you need to do as a data scientist, analyst, or as a developer too, is do some data cleansing and wrangling. With that, you would identify some set of features. And what are features? Features are some of the values in your data or attributes in your data which are very business critical, which will help you to determine whether the data is good or not. So once we have done all that, we have identified some features in our data, we need to select an algorithm, a machine learning algorithm. And most of the time, the algorithm selection would be dependent on what kind of data you have and what kind of question you're going to ask the model. So I'll quickly touch upon that section in my next slide. So once we have the data, once we have the algorithm which we know, we try to train the data with a training set. So generally when you have this data, you try to split them into 70, 20, 10. 70 for your training, 20 for your validation, and 10 for your testing. So that you know that model is able to evaluate what you want it to evaluate. Once you have the model, put it in production and start feeding your real-time data to the model, and it will start predicting results for you. It would most likely require tuning because there's nothing like first time you get it right, but how do you determine when you need to tune or improve your model? It would be based on some of the machine learning metrics which we get, like what's the F1 score, depending on what algorithm you have used, what's the bias, what's the recall. These are some terms around understanding how the results are coming out from the model. And last but not the least, monitoring your model is equally important because for the same problems, for those Vs, there could be a chance that the data changed, there's a complete data drift, or it could also happen that the whole question you're asking, that whole concept also drifted. So you need tools around to catch those and then retrain your model. But hey, isn't it better than writing rules for that amount of data? With that, I'll quickly touch upon some algorithms. So this slide is a bit old one, but I'm going to cover in a way where it gives better understanding. So there are many types of machine learning right now in the market, but if I can categorize them, it would be like supervised model. So supervised model are the one where, as a user, you would label the data for training the model. So you would like to put, hey, these are some good scenarios, these are some bad scenarios, try to cover as much as you can on the data. And then with that data, you train the model. With unsupervised model, there's no human labeling of data required. You would go ahead and let machine determine the correlation of the data and the groupings, how it forms, and form a cluster, and then feed the real-time data. And based on that understanding, machine will tell you, this looks like an anomaly to me, and then you can act on it. There's also reinforcement learning out there. I'm not going to cover that much today, but it's more of a trial and error, and it has a feedback loop through which we develop that. There are a lot of material out there. I'm not going to spend too much time here because I want to give you some actual examples. Rote learning. So it's a memorization technique, like how as humans in old times used, we tried to memorize as much as we could, right, when we didn't write. This model, I can say, is similar to that. This works for a categorical columns where you have some set of values in a column you expect on a daily basis in our case. And what you'll do, and if you can look around this bottom flow here, so once we know some columns which are of interest to us, again, those features, we will do a group by on them that will give us all the combination of field values which that column is expected to have. And in future, if any one of them, I won't go to the future yet, so we'll prepare a lookup table, a hash table with that list for each of the column which you have interest in. And then we will start feeding our real-time data. It will do a lookup based on that hash table. And if suppose I get a field which it had never seen before, it will alert. And then it can go to a subject matter expert and they can make a decision. And if we need to, again, put that field back into our model verification, in our model, we will do a retrain of the model and we'll continue. Very simple, but very effective. Most of the rules generally we write, we can try implementing that with categorical column.
Can I ask a question?
Yeah, sure.
So on those rules, those are ones that humans have written or rules that the machine has inferred?
It is what we taught machine that these are some of the rules by giving a group by on a particular column. So it's all machine. Sure. All right. LSTM. This is a recurrent neural network, another type of algorithm type. It's very good for time series data, and time series data is nothing but an event of, it's a set of events over a period of time. At FINRA, we do get a lot of that, you could imagine, because we work in the trading world. So it's like a neural network with amnesia, without amnesia, I should say. It's just like my wife, she doesn't forget anything. So what do I mean with that in terms of this model? Hey, in a good way, though. So it will remember anything from the past, and also it will reward signals from distant past too. So if you have found an issue with this model, it will have something in its memory, and if it sees again in the future, it won't forget and it will alert. So it's an incremental way of building a memory to a model where you can catch many issues. I don't want to go in detail because it's going to take a long time how we implement LSTM, but it's a very effective algorithm for time series data. And in this world, time series data has a lot of value. We all understand, I guess. Another one, this comes from the class of unsupervised learning, where we don't need to do much labeling of data and training of data of the model. Here, it will learn by itself. So it has two major pieces, if you see those two mushroom faces. So one is the encoder and other is the decoder. So what does the encoder do is it reduces the overall input data's dimension, and then the decoder will try to reconstruct the same value which we passed through the encoding, and then it will give us an anomaly score, which is great, which will tell us what's the probability of that being an anomalous record or an issue. But that also means we might have to set some thresholds on those, because sometimes, and I just want to quickly detour from this, sometimes, too many alerts is as good as no alerts. Right? So it's very important, and not only in this case, but in overall our data quality check practice, it's good to have some kind of understanding initially and set some kind of threshold on the results which we are getting. So coming to your question, again, machine can do many things for us, but it doesn't have the human mind. And sometimes the subject matter experts do need to pitch in, help the model stay in the lane and understand the data better. What's the future at FinRaf in terms of data quality? We are a data-driven company. I'm sure you saw those numbers. So what we are trying is to evolve in our overall data strategy, and we have created enterprise-level data governance practice, which we are trying to operationalize. I believe most of us are in that journey, as well as with what we have achieved with our machine learning checks. We want to implement more machine learning checks and also bring in those data quality stewardship where the producer consumers are engaged in this whole what we want to achieve, like no issue data. But it's a long path. It's a path which we are already on, and we will be there. Key takeaways. We would like you to have some takeaways which you can go and implement in your company. Data quality is important. Let's not talk about it. We all understand. One size does not fit all. Why? Different industry, different variety of data. We need to adopt to the data, and data is not going to adopt to us. So we need to keep that in mind. The next two are more around scalability, where machine learning kicks in. We don't want to use our resources to learn the language of the data. We want to let machine learn as much as it could, and then help machine through human knowledge. And apply as many models as you can in your overall data pipeline. Data quality metrics, very important. Sometimes it is left in the back burner, but that is the one which gives us the indication of overall health of the organization's data quality posture. And with that, we can always improve, because that will give us some sense of health of the data at the organization. So with that, we will always continuously improve and get into a fancy land where there is no issue in the data. And that will go to the questions.
Is there a way you can quantify how much you're relying upon the machine learning models versus the basic checks, like, I don't know, percent or importance, or any way to describe how much work you're doing through the machine learning models?
Sure. So the question is, how much we are quantifying, how much checks are we doing with machine learning, and how much we are doing with rule-based. So rule-based checks were already there, so we have good numbers based on the metrics which we have collected. But with machine learning, with the models we have, every time we have an issue, we mark that this is an accurate issue, and we build metrics on top. So we have roughly 15,000 objects data set in our ecosystem. And I can't put a number to it, but I would say this, that with machine learning checks, we have been always putting our bar up in our data quality. And I'll let anybody else speak.
Yeah, I just want to add a few things on top of what Abhishek said. We have a constant retraining model where we have some monitoring in place which constantly goes and checks whether the model is exhibiting the metrics that we want, is the bias or drift or whatever the model is supposed to do. We have a loop back, and then the retraining constantly helps us to be on top of that. Yeah.
In terms of supervised and unsupervised learning, from your experience, which is more effective?
The question is like supervised and unsupervised model, which is more effective? You want to answer it?
Yeah, so currently, at this time, supervised learning has been working good for us because, again, there's a human mind labeling of the data which has gone in. But ultimately, if you want to scale, even in machine learning, unsupervised learning is the one which will take us to that high level of overall data quality governance. So currently, it's at our organization, it's supervised learning.
A lot of times we don't know the data format or new data coming in. Unsupervised automatically knows that. Yeah, it cuts down the effort as us going and labeling and then marking the data and analyzing the data.
Yeah, one other thing I'll quickly touch upon, unsupervised learning sometimes is a bit difficult to get it right, which also brings more time. So I understand we're thinking labeling will take time, but to get unsupervised learning correct at times for the business need is also time taking. So it's a balance. And
Yeah, the
depends on
validation.
data and the algorithm which you want.
With the validation and testing takes time. So it's a balance. Yeah.
Really nice presentation. It's nice to see all the things that you've done. As a reality check for people that are starting this, can you give us an idea of the timeline from when you started doing this and where you are today?
Yeah, the question is, can you give us the timeline as to our journey when we started? So I'm going to answer from my side, but I'm definitely, Troy will answer from his side of the story. As I, let me complete the answer, right? As I shared a story in my slide, 2016, that's like a breaking point where we realized that we migrated to cloud a few years before that, and we then realized that we have to stay on par with the technology and identifying issues. And that one incident of, regulatory compliance, it's called Reg SCI. I don't know how many of you heard that, but it's a compliance event where we have to report SEC, and our SVP and executive SVP standing in, I was leading operations, so he was standing in front of my desk, and then what can we do to really mitigate this? We actually had a technology offsite, like we all went, and it was like a couple of days brainstorming session. And then I would say since then, we continuously evolve and continuously expand the checks. So it did take long time to get to this state. And as Abhishek was showing, we really have a lot of future thoughts, and we wanted to be even more solid state. Do you want to share?
Probably not from the data quality side of things, but we've also tried to implement that on the surveillance side of things, machine learning. So we have a number of patterns and surveillances now that are machine learning. It took a lot of convincing to get the business to buy into that, right? So that was an extended period of time. We probably started that 7+ years ago to try to go through that, and it was a slog to get there. It was, and the first iteration of that didn't necessarily look really great. So that even created more issues with the business. But we're well past that now.
Yeah, I have one question. On your models, you build it, machine learning models, what's the LSTM and the neural network, you do that in TensorFlow or PyTorch or something like that?
Yeah, so thankfully at our organization, we have various platforms which we can use. And yes, TensorFlow, PyTorch has been used. We also have Dataiku and Domino as a platform for data analytics, which we are using. So we got various tools at our disposal to build these.
So we developed the model in Domino and then we deployed it in PyTorch.
Yes.
Yeah, we also have, just to add on to that, we use SageMaker, AWS services, and some of the models are like running through EMR clusters with Spark code in it. So it's a combination of the model languages we use. It's not like one size doesn't fit all. So it's like different models in different platforms. And to run the models, the analytics tools are Dataiku and Domino. That's we use at FINRA.
And how do you decide to do stuff for one cloud or you're saying doing a lot of your stuff on-prem?
So we migrated almost 95% of our infrastructure applications to the cloud. So there's very small footprint, which is like COTS applications left on premise.
Thank you.
Any other questions? All right, thank you all.